The problem with visual analysis techniques is that they are inherently qualitative and subjective. Statistical analysis techniques for single subject and small n designs exist, but there is no agreement on which approach is best. More importantly, statistical analyses that produce a p-value are suspect at best. I recommend that you ignore p-values for single subject and small n designs. A celeration line is calculated so that half of the data within a phase falls above the line and half falls below. The celeration line represents the trend of the data from one phase and is extended to the adjacent phase. If there was no difference between the phases, then we would expect half the data points in the adjacent phase to be above the line and half below. The further the data is from that situation, the stronger the evidence that the intervention had an effect. In the graph shown on this slide, the celeration line is calculated for the data in the A phase and extended into the B phase. Almost all of the data points in the B phase fall above the celeration line, which is evidence that the intervention had an effect. The celeration line can be combined with the binomial test to produce a p-value. The binomial test is used to determine if there is a statistically significant difference between the percentage of points above the celeration line and 50%.